Hello everyone, and thanks for joining another episode of the Trellix Spotlight series. We're going to wait another minute to give everyone a chance to get connected, and then we'll get started. Welcome to the Trellix Spotlight series. My name is Nick, and I will be your host. Today's session will focus on the endpoint security for Linux installation process and troubleshooting. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact Trellix Technical Support. If you have questions during the webinar, please type them in the Q&A window. This webinar may run longer or shorter based on your participation, and we recommend asking as many questions as you can to make the most of this series. If the Q&A window is not displayed, click the tab at the bottom of your session window and click on the Q&A icon. We will answer the questions during the final section of this webinar. If you experience any audio issues during the webcast, please drop and attempt to reconnect. Our presenters today are Nitisha Awasthi and Revathi R. Nitisha has over 4 years of experience with McAfee products. She specializes in supporting non-Windows platforms and is currently providing support for all Mac and Linux endpoint products. Revathi is working as a technical support engineer with expertise in McAfee Mac and Linux products over 3 years with the company. She currently delivers support and KB creation for all Mac and Linux endpoint products globally. Ladies and gentlemen, Nitisha and Revathi.
Thank you, Nick. Hey everyone, and thank you all for joining today's session. This is Nitisha along with my colleague Revathi. Let's quickly go through our agenda for today. Endpoint security for Linux is having two modules, which is threat prevention and firewall. In today's session, we would be covering up the installation process of threat prevention module, kernel compilation process, understanding installation with SELinux enabled machines, understanding installation with secure boot enabled machines, and at the end, we would be concluding with generic installation errors and its resolution. Let's begin with our first topic to understand the ENSL installation process. Before we plan of installing the product, there has to be certain prerequisite check. The first is to check on the OS compatibility, which could be seen in KBA 87073. If the product is compatible with the OS, we can decide on the installation type. As we all are aware, we have two methods of installation. It could be either deployed through EPO or a standalone installation. If we are going with the standalone installation, based on the system configuration, we can select the packages. If the system is not configured with SELinux, we can go with normal installation package. In case if the RHEL system is configured with SELinux, we can go with SELinux compatible RPM package. What happens if the product is not compatible with the OS? In that case, you can raise a PER request or submit a request with the support so we can take it further from there. Apart from OS compatibility, ENSL does have some hardware and software requirements too. As we can see in below table, it only supports two type of processor, that is Intel based and AMD based architecture. To install ENS, we require minimum 2 GB of RAM but we recommend it to be 4 GB. Moving on to disk space, the installation directory of ENSL requires 2.5 GB of space. OPT McAfee directory requires 750 MB space. In temp directory, we need 1 GB of free space. In var directory, it requires minimum 3 GB of partition, whereas 750 MB free space is needed. ENSL also have dependency on Python modules. We must have Python 2.x or higher installed on the system in order to proceed with ENSL installation. Now let's take a look at the demo. First, let's start with how do we push ENSL from EPO. Let me log into EPO console. I have these two systems already managed by EPO. I have installed agent on these two. Let me pick any one of the system and will create a deployment task to push ENSL on this system. I have selected it, go to action, agent, edit task on a single system. For now, I don't have any of the tasks created for this machine. I'll create one. Product has to be McAfee agent. Task type product deployment. I'll create a new task. Let me name it as ENSL. Target platform has to be Linux. From the dropdown, I'll select the package, which is McAfee Endpoint Security Linux Threat Prevention. Action has to be installed. I'll save it. Schedule it to run immediately and save the task. After saving the task, we have to give wake-up agent call to the system. It usually takes some time in order to reflect on the client machine. Meanwhile, let's have a look how we can perform a standalone installation of ENSL. I'm having this RHEL 8.6 machine and I have moved in the required packages. For now, this machine is not having any of the McAfee product installed. As ENSL also have dependency on agent, we'll first install agent on this system, followed by ENSL installation. Let me unzip the agent package. We have the install.sh file. I'll provide required permission to it. And execute the installer. I'm using -i here. -i is used for fresh installation of agent. The execution has started. Let's give it a moment. Okay, the agent is successfully installed on this system. Let me check the services once. All the three agent services are running on this system. Let's proceed with ENSL installation. Before that, let me clear the screen. I'll extract the McAfee TP package. Here is our installer, install mfetp.sh. I'll execute that. The execution has started. These are license and agreement. Press enter to go through these. If you want to avoid reading these license and agreement, you can use silent switch after the installer. It will perform the silent installation of the product. I'll accept it. Okay, the installation is completed. It will now try to update the default that update task and enable OAS. Okay, the execution has completed. Let's validate if services are running on this system or not. Okay, the service is loaded and it is active and running. However, if you can see, there is some error for module reusability and RKMS for AAC kernel module. Let me check if MFE kernel modules are loaded on this system or no. Okay, for now, I cannot see any of the McAfee kernel module loaded. Let's check if all the modules of ENSL are enabled or not. I'll go with OAS first. Okay, the OS is enabled and non-compliant. Let's see the AP status. AP is disabled on the system. Let me check EP status. EP is disabled too. What happens if I'll try to enable these modules? Let me try enabling AP. Okay, it's bailing out with an error. Let's try with EP2. The same error is seen for EP as well. We'll discuss about these errors and how do we resolve in our further slides and demo. Moving on to our next topic, which is kernel compilation process. Kernel plays a major role in the functionality of ENSL. Hence, in order to avoid any functionality error, we recommend ENSL to be installed on supported kernel version. Kernel supportability can be seen in below mentioned KB articles. These are for different distributions. For Ubuntu, it can be checked in the product release notes. If the kernel is supported with the product, we can go ahead and proceed with the installation. If not, then we can recompile the kernel using KB article 89912. In the standalone installation, we saw an error for kernel support mod versioning and RKMS. That was because the running kernel on the system wasn't supported with the product. Hence, it started reusing the supported older kernel version present on the system. When the kernel is not supported, ENSL fails to load MFE file access and MFE AAC kernel modules on the machine, resulting in product discrepancies. If the recompilation works, we would not be seeing any functionality errors with the product as such. If not, please raise a ticket with Trellix support and it can be investigated further. Let's see this in action, how recompilation exactly works. In the last demo, we saw we were having trouble while enabling access protection and exploit prevention module. The main reason behind that is the running kernel on the machine is not supported with ENSL. Hence, we were getting error while enabling these modules. Now let's recompile the kernel and see if that helps to resolve our issue. Before that, let me clear my screen. We'll first install the development tools. The execution has started. All right, that's finished now. Next, we'll install the kernel devel package. The execution has started. Looks like the package is already installed. Let me restart the MFE TPD services. As we have already recompiled the kernel, once the services are restarted, we'll try enabling access protection and exploit prevention module. Okay, the services are restarted. Let me try enabling AP, which is access protection module. AP enabled successfully. Let me try the same with EP. EP also enabled successfully. Now we are able to enable these components without any error. Coming to our next topic, which is understanding ENSL installation on SELinux enabled machines. Let's understand what is SELinux. It's a security mechanism implemented in the kernel for applications, processes, and files on the system. It only allows access based on the SELinux policy rules configured. It is having three different modes. The first is enforcing mode. It enforces the policy rules and allows access based on those policy rules. The next is permissive mode. It only logs those actions that would have been denied if running in enforcing mode. In layman terms, it's basically a diagnostic state where SELinux policies are not enforced on the system. Third is disabled mode. No policy is loaded in the kernel. ENSL, also being an application, can support SELinux policy, and we do have an outlined procedure for the same. In order to configure these policies, we must have RHEL 7.1 and later or RHEL 8.x and before. Let's take a look at the demo to see how these policies can be configured. This is RHEL 7.9 machine where we have already pushed ENSL from EPO. Let's validate the product version. So the ENSL version installed is 10.7.10. Let me check the SE status. So SELinux is running in enabled mode and it is enforced. Now we'll install the SELinux compatible packages for agent and ENSL. I have already copied the required packages to this machine. Let me navigate to that directory. So these are the two packages. Before we apply SELinux policies for ENSL, we need to make sure that McAfee agent is also running in confined mode. So I'll start with configuring McAfee agent policy first. Let me extract the package. Navigate to release packages directory. Here we can see we are having two RPM packages. One is for RHEL 7.x and the other one is for RHEL 8.x. This is RHEL 7.9 machine. So I'll execute the first one. So the execution has started. Let's give it few minutes. It started loading the SELinux policy for MFE MART. Cool. It loaded the policy for the second module as well. Okay, the execution has completed. Let me check if the SELinux policy modules are loaded appropriately or not. Okay, so it is loaded correctly. MFE MA and MFE MART. Let's verify if the McAfee agent processes are running in SELinux confinement or not. So yes, we can see here the McAfee agent processes are running in SELinux confinement. Cool. Let me go to the previous directory and I'll start the execution of ENSL SELinux package. Let me extract the package. Navigate to release packages directory. We can see here as well, we are having two RPM packages. One is for RHEL 7 and for RHEL 8. Let me execute the package one for RHEL 7. All right, the execution has started. The policy is loaded for the first module. The execution has completed now. Let me verify if the SE module are loaded for these packages or no. Here we can see the SE module is loaded for all the four components of ENSL, that is ESP, firewall, RT, and TP. Let's verify if ENSL process are running in SELinux confinement or not. So here we can see all the four modules are running in SELinux confinement mode. This is how we can configure the SELinux policies for agent and ENSL. Thank you all. I hope the information shared is useful. Over to you, Revathi.
Thanks, Nitisha. Hello, all. Installation with Secure Boot enabled and generic installation and errors are the topics which I'll be covering in today's session. Let's start with installation of endpoint security for Linux with Secure Boot enabled. Let's see what is Secure Boot. Secure Boot is all about the trust The idea behind it is starting the machine in safe way in order to prevent the computer running the malware from the beginning. In layman terms, this feature will block the unsigned packages. It will not allow the execution of packages without the security key. There are certain advantages and disadvantages. Advantages are it protects the machine from the attacks and infection from the malware. Disadvantages are there are chances where authorities can make mistake in granting the signature or loading the ashes. That's the reason we need to have AV in the Linux box. This is where we come into picture. Now let's see secure boot with ENS. Here the TP component uses a kernel module to grab the files which performs IO operation for scanning. Kernel modules, which has been shipped for endpoint security for Linux threat prevention, are not being signed for secure boot. Since the packages are not being signed, it does not load the unsigned modules. Even though the installation of endpoint security for Linux is successful, the components will not be enabled and it doesn't work as expected. There are certain errors which are being seen in mfetpd.log. Here, the log clearly explains or shows the error message stating that module insertion failed with error, required keys are not available. Let's see how to overcome the scenario in the demo session. For today's demo session, I'll be using this as my test machine, which has operating system Red Hat Enterprise for Linux 8.5 version. In this session, let's check how to see if the components of threat prevention are allowed or not. Also, let's see what are the steps we have to perform to make the components work. As part of best practice, let's see if the product has been installed in this machine by executing the command rpm-qa grep-i mcafee. The output says that we have threat prevention 10.7.10 installed in this machine. Now let's check for the component status one by one. Let's see the access protection status by executing command. We could see that access protection is in disabled state. Now let's check for exploit prevention status by executing the command. Exploit prevention is also in a disabled state. Now let's check for on access scan summary. We could see that on access scan is enabled, but it is in non-compliant status. Since all the components are in disabled state, next step which we usually do is to check the mfetpd.log. Now let's navigate to the file location. Let me cat the file log file and grep it with the keyword error. This syntax would search for the error word in the log file mfetpd.log and displays the output of it. We could see that there are multiple errors recorded stating module insertion failed with the error required key is not available. Now let's check for the secure boot status in this machine by executing a simple command. We got to know that there is a secure boot which has been enabled in this machine. Let's now try to get the security key for this packages and load the modules and make sure components work as expected. As part of prerequisite, we need to install certain utilities one by one. By executing the command m install. We shall try installing the utility of SSL. OpenSSL utility is used to generate a private and the public key in the machine. Now we shall install another utility called kernel dev by executing the command yum install kernel dev. This utility is a Perl script which is used to sign the kernel modules. And the last utility which we would be installing is mockutil by executing the command m install mockutil. This is used to manually enroll the public key. Now we have installed all the required utilities in the machine. Since my machine has been updated with all the dependencies, it just gives a message stating nothing to do and it has been complete. Now let's try to create a configuration file for generating the private and the public key by executing the command cat eof, and I would be giving the file name as ENS underscore configuration underscore file dot config. Here, once the file has been created, we have to give certain entries. This entries would be like what is a corporation which we would be using and the organization signing key, email address, and what are the type of string mask we would be using and extension which we would be using. Now, once the configuration file has been created, let's try to generate the private and public key by using the utility open SSL. Required extension is -x509. This is for new nodes, so I would be executing the command as new nodes. String mask is UTF-8 using the SHA method 256, and that is 3650 patch. And let me call the configuration file here outform dir -out, and let me create the public key first. Underscore key dot dir -key out, and let me create the private key underscore key dot priv. Now we have generated a RSA private key and we have returned it to the ENSL private key file. Now let's try to find the file access module to sign it by executing the command ls-lrt and lib and this output gives us the file path where we would be signing the key. Now let's try to execute the command to sign the keys. Do src kernel. Let me give the kernel version. Scripts. I'll be using the file sign file with the method SHA-256. And here I'll be mentioning the private key path /root and I'll also call public key path, and I'll mention the file path which it is reflecting here /var McAfee ENS ESP file access kernel, that's kernel version, and Now the file has been successfully signed. That's the reason we did not get any error message. Same way, let's try to find the path for AAC, arbitrary access control, and we shall sign it as well. ls-lrt/lib modules $uname -r, and let me give the file name mfe_AAC. And this will give the output of the file path where we have to sign the file. Now let's try to sign the file here by using a command /usr src kernel version script sign file with the SHA-256 method, and let me call the private key. Let me call the public key as well. And let me mention the file path which it has to be signed. ENS, ASP, AAC, kernel. Let me give the kernel version. And let me sign this file as well. Since it has been successfully signed, we haven't received any error message. Now we have created the keys, we have signed the keys. Let's try to import the key to the machine by using the mockutil command. -import. Let me call up the public key file path here. Once you call up the file path, it would be asking you for the password. I would suggest you to give a simple password and remember it, because we should be using this password in the MOK management enrollment. Once the password has been confirmed, the next step which we have to do is like restart the machine. It might take a minute or so. Let's wait for the machine to come online to perform the mock enrollment. Now, click any key to start the mock enrollment. Select on Enroll MOK. Now, if you have to view the key, you can click on View, and you can see the organization sign-in key and for what days it has been valid and the fingerprint of it. Once the view has been completed, you can click on Enter and click on Continue. For enrolling the key, click on S. And remember, I had said to remember the password. You have to fit in the same password here and click on Reboot. Once the system comes online, we shall try to see if the components are in enabled state, and let's check the status of each and every component. Once the system is up, we shall try checking the component status one by one. Let's see the status of access protection. It is in enabled state. The same way, let's check for exploit prevention as well. We could see that exploit prevention is also in an enabled state. Now, let's try to check the status of on access scan. And we could see that on access scan is enabled and compliant. Now let's try to verify the file if the file module has been loaded by executing the command lsmod grep mfe. We could see both the file access and arbitrary access control both have been loaded. Steps which I have performed in today's session to enable ENSL component in the secure boot machines is also available in a Trellix KB article KB 90085. I would suggest you to refer this article when you are performing this activity. The next topic which we would be discussing in today's session is generic errors while installation. There are certain error messages which we usually see at the time of installation. Under install log, we sometimes see a message stating no space left on the device. Before we proceed with ENSL installation, we have to check for the space availability in the machine. If the device is running out of space or if we have the space less than the requirement, we end up seeing the message as per the screenshot. Hence, Trellix always recommend to have 2.5 GB of space in the installation directory for the successful installation. When we push the deployment package from EPU, by default it starts to install from the temp folder. By chance, if we are running out of space under the temp folder, we can change the default location by using the command alt temp path is equal to var as per the screenshot. Another generic error which we usually see is McAfee agent dependency. Even though we have a higher version or the compatible version of agent in the machine, we sometimes see a error message as per the screenshot. Reason, we might have installed the McAfee package of 32-bit. In this scenario, when we try to perform the ENSL installation, it bails out. Hence, we would suggest to install the McAfee agent package of 64-bit for the successful installation. Most frequent and the generic error seen at the time of installation is Python is not available in the machine. As a prerequisite, we would need to install Python for the successful installation of ANSL, or else we might end up facing an error as per the screenshot. Trellix always recommends to have Python 2.x or the IO version in the system. Now, let's see the demo of the error which we've discussed. In this session, let's see the demo of generic errors which we discussed. The first error message which we discussed was no space available in the machine. As an initial step, let's check for the space availability by executing the command df-k for the folder temp. We see that the available space is 560 and the usage is 100%. It clearly states that we don't meet up the prerequisite which was mentioned earlier. Still, let me try to execute the installation file to show up the error message. We could clearly see that it gives up an error message stating insufficient disk space under temp folder to execute the installation file. Now, let me delete the dump file which I've copied to the system to occupy the space, and then let's try to perform the installation. Let me try to execute the installation file. Now we could see that installation proceeds further without any issues. As said earlier, kindly make sure when you perform ENSL installation, you have around 2.5 GB of space available in the machine. Now we could see the message stating that installation has been successfully completed in this machine. and the components are getting enabled one by one. And finally, this TP is ready for use now. As said earlier, kindly make sure you have around 2.5 GB of space in the installation directory to get the product installed successfully and work as expected. Now we shall see how to install EPO deployable package by using a different folder. Let me try sending the deployment task from the EPO. Select the machine, click on Actions, Agent, Edit task on a single system, click on New Client Task Assignment, select the product as McAfee Agent, task type as Product Deployment, click on Create New Task. Here, give the task name as Demo and select the target platform as Linux. Select the package to be deployed here. Here in this command line, if we do not give any command, it tries to execute from temp folder by default. Since I have to change the installation to var, let me use a command alt tmp path is equal to /var and click on Save. Let me select the task type as Run immediately and let me click on Save here. Once the task has been saved, let me select the machine and give a wake-up call. Once this has been done, let me quickly go back to the Linux box and see the log file. The installation happens from the var folder, but the log file will reside in the temp folder, and we could see that the installation has been proceeded without any issues. Let's see the log file again to check if the installation has been completed. We could see installation has been completed successfully without any issues. Let me check the product details by executing the command rpm-qa grep-i McAfee. We could see product has been successfully installed. The next error which we saw was McAfee agent dependency error. ENSL supports only 64-bit operating system and the installation package. Here, in this scenario, let me try installing 32-bit McAfee agent package in the machine and let me execute the installer to see the error message. To install 32-bit package, let me execute the command rpm-ivh and mfert. This will install the runtime package and we could see it has been installed successfully. Same way, let me try installing the MA package. Agent is also installed. Now let me try installing a DXL package by executing the command rpm-ivh and the package name. Now all the required packages has been installed in the machine. Let me execute a command and check for the agent version installed in the machine. We see McAfee agent version installed in this machine is 577, the highest version, and this is also compatible with the operating system which we are using. Let me try executing the installer package of ENSL. Here we could see even though we have a higher version of agent and the compatible version, still the installation failed. We could see the error message stating is MFE CMA x86 577378 is unsupported. Let's uninstall McAfee agent and try executing the 64-bit installation package. Now I've uninstalled the 32-bit agent and now I would be installing the 64-bit version. The 64-bit agent has been installed now. Let me try installing the DXL. We've installed DXL as well. Now we have all the 64-bit agent package available in the machine. Let me execute the installer now to see if it proceeds further. We see the installation is proceeding further without any issues. Installation has also got completed successfully. Now the packages have got installed successfully in the machine. This is the reason Trellix always recommends to have 64-bit package for the successful installation. The last error which we saw was installation of ENSL fails due to Python dependency. Let me try to execute the install file. Here we could clearly see a message stating Python is not available in this machine. Install Python and try again. Let me try installing the Python in this machine. The last error which we saw was installation of ENSL fails due to Python dependency. Let me try to execute the installation file to see the error message. We could clearly see a message stating Python is not available in this machine and it is asking us to install the same. Let me install the Python in this machine. We have successfully installed the Python in this machine. Let me try to execute the installation file again. We could see that installation proceeds further without any issues. Installation says as completed. Post installation of Python, we were able to see the successful installation of ENSL. Hence, Trellix always recommends to have Python with 2.x or the higher version. Hope the information which has been shared in today's session will be helpful. Thanks everyone for joining this session.
Thanks, Nitisha and Revathi. As a reminder, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on the screen to see all of our offerings. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated.
CentOS is built on RHEL. Can we configure SELinux policy on that as well?
Let me take this one. Currently, SELinux ENSL package are only designed for RHEL machines. So for now, it cannot be used on CentOS.
Got it. Okay, cool. Thank you for that. Why does the agent have a 32-bit package when ENSL is only supported on a 64-bit platform?
Let me answer this. Earlier, we had only VSCL and command line scanner, which was supporting Unix 32-bit platform. That's the reason we had agent of 32-bit version. Now, 32-bit. Now ENSL only supports 64-bit platform, and it requires 64-bit agent package to be installed as a prerequisite.
Got it. Okay, cool. Thank you for that. Do we have an EPO deployable SELinux package to configure ENSL policies?
Okay, this is a good one. Let me take this up. As of now, MA and ENSL SELinux package has to be installed manually because they are designed like that way. And we do not have any EPO deployable package for policy configuration.
Got it. Okay, cool. Thank you for that. Is it possible to automate the procedure for signing ENSL kernel modules?
This is a good one. Let me take it up. We can't really deploy an automated process to avoid manual sign-in of kernel modules because it necessitates manual steps in which the end user must go to the mock console and select the newly generated public key during the key enrollment process. So for now, we don't have a automated process. This has to go on in a manual way.
Got it. Okay, cool. Thank you for that. If we have no exec permission in the temp directory, will we be able to install ENSL on the machine?
Let me try answering this. Indeed, yes, we will be able to install ENS if the temp directory has no exec permission. We just need to the switch or the command alternate temporary path and specify the directory name where the execution of the installer has to happen. Just make sure the directory where we are extracting the package should not have no exec permission set. It has to have standard permission set, and that should take care.
Got it. Okay, cool. Thank you for that. Is it necessary to have the threat prevention package and ESP kernel module package in the same branch?
Let me take this up. Yes, it is necessary to have ENSL build and the ESP kernel module package in the same branch because at the time of installation, ENSL build will have a pre-check on the checked in ESP module package of the same version. Example, if ENSL 10.7.10 installed package is loaded in the current branch, the ESP kernel module should also be loaded in the current branch. If not, the installation of ENSL will bail out.
Got it. Okay, cool. Thank you for that. I only noticed the EL7 and EL8 RPM packages for SELinux. Can we use it for RHEL 9 as well?
Let me take this up. Currently, ENSL SELinux packages can only be used on RHEL 7.1 and later or RHEL 8.x and before. So no, we cannot use the same package on RHEL 9, but there is a possibility of a separate package. At this point in time, I would say stay tuned for more updates.
Got it. Okay, cool. Thank you for that. Is there any specific Python module ENSL will look for?
Yeah, let me take this up. ENSL will use Python XML or Python LXML modules to function. The reason behind using this Python modules are to check if there is any sort of corruption in prefix.xml. It uses validate prefix xml.py module, and there is a migration script too called mfetp.py to migrate the DAT policies and engines in the case of product updates. So both Python.xml or Python-LXML modules are used to run, and Python is required as a prerequisite.
Got it. Okay, cool. Thank you for that. It looks like that's all the time we have for today's session. I want to thank everyone for joining today's webinar, and a big thank you to Nitisha and Revathi. As a reminder, a link to today's recorded presentation will be emailed to all participants. This concludes today's webinar. Stay safe, everyone.